Ever pondered on how to manipulate arrays in JavaScript? Well, worry no more. Today, we will delve into some of the most commonly used array manipulation methods in JavaScript. First, let's discuss the push method. This method adds one or more elements to the end of an array and returns the new length of the array. For instance, imagine an array with elements 1, 2, 3. By using the push method and adding 4, the array becomes 1, 2, 3, 4. Now, let's move to the pop method. This method removes the last element from an array and returns that element. So, if you have an array with elements 1, 2, 3, and you use the pop method, the array becomes 1, 2, and the method returns the popped element, 3. Next up is the shift method. This method removes the first element from an array and returns that element. This operation changes the length of the array. For example, if you have an array with elements 1, 2, 3, and you use the shift method, it will return 1, and the array will become 2, 3. The unshift method is up next. This method adds one or more elements to the beginning of an array and returns the new length of the array. So, if you have an array with elements 2, 3, and you use the unshift method to add 1, the array becomes 1, 2, 3. Let's talk about the slice method. This method returns a shallow copy of a portion of an array into a new array object selected from start to end, with the end not included. The original array will not be modified. For instance, if you have an array with elements 1, 2, 3, 4, 5, and you use the slice method to slice from index 1 to 4, it will return a new array with elements 2, 3, 4, and the original array remains unchanged. Lastly, we have the splice method. This method changes the contents of an array by removing or replacing existing elements and/or adding new elements in place. For example, if you have an array with elements 1, 2, 3, 4, 5, and you use the splice method to remove one element starting from index 2, the array becomes 1, 2, 4, 5. You can also use the splice method to insert elements at a particular index. If you insert A and B at index 2, the array becomes 1, 2, A, B, 4, 5, 4. In conclusion, these array methods are fundamental for manipulating arrays in JavaScript. They are widely used in various applications and are crucial tools in every JavaScript programmer's toolbox. So keep practicing, and soon, these methods will become second nature to you.
Ever wondered about the ForEach function in JavaScript? Its beauty lies in its simplicity and efficiency. Today, we're diving into the heart of this function, bit by bit, to uncover its potential. The ForEach function, a higher-order function in JavaScript, is a tool to traverse each element of an array. It's like an efficient tour guide, leading you through each item in the array without missing a single one. The function operates by executing a callback function for each element in the array. This callback function can do anything you want with each array element, giving you a lot of flexibility. The syntax of the ForEach function is quite straightforward. Imagine you're commanding an array to perform a specific task for each of its elements. In JavaScript code, it would look like this: array.forEach callback current value index / code block to be executed. Here, callback is the task you're asking to be performed. It's a function you provide to be executed for each element in the array. The current value is the array element currently being processed. Think of it as the individual item in the array that the callback function is currently working with. Optionally, you can also include index, which represents the position of the current value in the array. Another optional parameter is the array itself, which is the array that the ForEach function was called upon. One key point to remember is that the ForEach function does not mutate the original array. It's like a considerate guest, leaving everything as it was found. Let's illuminate this concept with an example. Suppose we have an array of numbers. We can use the ForEach function to log each element and its index to the console. The code would look like this: const numbers equals sign, numbers, ForEach function item index console.log. This would output each element and its index starting from 0, like so. Element at index 0 is, 1 element at index 1 is, 2 element at index 2 is, 3 element at index 3 is, 4 element at index 4 is, 5. In this example, the ForEach function is taking a tour of each element in the numbers array. For each stop on the tour, it executes the callback function, logging the element and its index to the console. To summarize, the ForEach function in JavaScript is a powerful tool for iterating over array elements. It's simple yet flexible, allowing you to define exactly what operation to perform on each array element. And importantly, it respects the original array by not mutating it. So, when coding in JavaScript, remember to take advantage of this efficient tour guide through your arrays.
Ever wondered what the map method in JavaScript is or why it's so important? Well, today is your lucky day because we're going to dive deep into its workings, syntax, and practical examples. Starting with the basics, the map method is a powerful JavaScript tool that creates a new array by calling a function on every element in the original array. It returns a new array of results with the function applied to each element. Here's the syntax. The map method is called on an array, and it takes a function as its argument. This function can have up to 3 parameters: the current value, which is the current element being processed in the array, the index, which is the index of the current element being processed, and the array itself, which is the array the map method was called upon. Now, let's see how this works in practice with some examples. Imagine an array of numbers and we want to double each number. We can achieve this using the map method. The end result would be a new array with each number doubled. Or perhaps we have an array of fruit names written in lowercase and we want them all to be in uppercase. Again, using the map method, we can create a new array with all fruit names in uppercase. The map method isn't only limited to arrays of numbers or strings, it can also be used with arrays of objects. Suppose we have an array of person objects, each with a name and age property, and we want to create a new array with just the names. The map method can help us achieve this. Finally, we can use the map method to calculate the square root of numbers in an array. So, what's the takeaway from all of this? The map method in JavaScript is a powerful tool for transforming elements in an array. It offers a concise syntax for carrying out transformations without the need for explicit iteration. It's immutable, meaning it doesn't change the original array, but instead creates a new one. It promotes a functional programming style, leading to cleaner and more declarative code. However, it's not without its drawbacks. While convenient, the map method can introduce a performance overhead, especially for large arrays or complex transformations. It may not always be the most appropriate choice, especially if the transformation logic is complex or involves side effects. Lastly, the callback function passed to map must be a function expression, which can sometimes lead to less readable code. That's it for the map method in JavaScript. It's a versatile tool to have in your coding arsenal, helping you to manipulate arrays with ease. So next time you're faced with an array that needs transforming, why not give the map method a try?
Have you ever wondered how to filter out elements from an array in JavaScript? Well, the filter method is a powerful tool that can help you do just that. The filter method in JavaScript creates a new array with all elements that pass the test implemented by the provided function. It does not change the original array. The syntax for the filter method looks like this. The filter function is called on an array and takes in a function as an argument. This argument function should return either true or false. The function is applied to each element in the array in turn. If the function returns true for a particular element, that element gets included in the new array. If it returns false, the element is left out. The function you pass into the filter method gets 3 parameters: the current element being processed, the index of the current element, and the array filter was called upon. Output. Let's consider an example. Suppose you have an array of numbers and you want to filter out only the even numbers. Here's how you can do it using the filter method. The filter method iterates over each number in the array, checks if the number is even, and if so, includes it in the new array. The result is a new array with just the even numbers. Output: scene script. But what if you want to filter strings? Say you have an array of names and you want to select only those that start with A. The filter method can handle that too. The filter method can even work with arrays of objects. Suppose you have an array of person objects and you want to filter out only those who are over 30. Here's how. Output: the filter method is a powerful tool for selecting specific elements from an array based on custom criteria. It provides a concise syntax for selecting elements based on a given condition without the need for explicit iteration. It does not mutate the original array. Instead, it creates a new array with the filtered elements, leaving the original array unchanged. The filter method promotes a functional programming style by allowing you to apply a predicate function to each element of an array, which can lead to cleaner and more declarative code. And often, using filter results in more readable code compared to traditional loop constructs, especially for simple filtering conditions. However, while filter provides a convenient way to select elements from an array, it may introduce a performance overhead compared to traditional loops, especially for large arrays or complex filtering conditions. And in some cases, using filter may not be the most appropriate choice, especially if the filtering logic is complex or if side effects are involved. So there you have it. The filter method in JavaScript is a powerful tool for filtering elements from an array based on any criteria you provide. It's easy to use, flexible, and can greatly simplify your code. Remember, the key is to provide a function that returns true for elements you want to include, and false for those you want to exclude. Happy coding!
Ever pondered over how to sum up values or find the maximum value in an array using JavaScript? Well, today we're diving into the world of JavaScript's reduce method, a powerful tool that can simplify these operations. The reduce method is all about executing a reducer function on each element of an array, culminating in a single output value. From summing up numbers to concatenating strings, this method is a game changer. But how does it work? The syntax of reducem is as follows: array reduce callback, accumulator current value index. Here we have several parameters at play. The callback is a function that gets called for each element in the array. This function takes 4 arguments: accumulator, current value, index, and array. The accumulator, as the name suggests, accumulates the return values of the callback. It's essentially the result from previous iterations. The current value is the current element being processed in the array. The index, which is optional, is the position of the current element in the array, while array is the array on which reduce was called upon. An optional initial value can also be used as the first argument to the first call of the callback. If no initial value is provided, the first element in the array is used as the initial accumulator value and skipped as the current value. Now let's see the reduce method in action. Assume we have an array of numbers, 1, 2, 3, 4, 5. We want to sum up these values. Here's how we can do it. Const numbers equals sign, const sum equals sign numbers, reduce, accumulator current value equals sign, accumulator plus current value 0. Console, log sum. In this example, the output will be 15, the sum of all numbers in the array. Now what if we want to find the maximum value in an array? Here's how we can achieve this. Const values equals sign, const max equals sign values, reduce, accumulator current value equals sign, mathmax accumulator current value values, console log max. In this scenario, the output will be 30, the maximum value in the array. By now, you should have a good grasp of the reduce method in JavaScript. It's a powerful tool that allows you to perform operations on each element in an array and reduce it to a single output value. Remember, the accumulator stores the return value of the callback function, which is remembered across each iteration throughout the array, resulting in a final accumulated value. So the next time you find yourself needing to sum up values, find the maximum value, or perform similar operations, think reduce. It just might be the solution you're looking for.
Ever grappled with the task of reducing an array from right to left in JavaScript? If so, today, we delve into the ReduceRight method. This function can be a game changer, especially when you need to traverse an array from the last element all the way to the first one. The ReduceRight method applies a function against an accumulator and each value of the array from right to left, reducing it to a single value. The method executes the provided function once for each element present in the array. It passes 4 arguments: the initial value or value from the previous iteration, the current element value, the current element index, and the array over which iteration is occurring. To illustrate this, consider the following syntax: array, ReduceRight, callback accumulator, current value, index, array, initial value. Here, the callback is a function to execute on each element in the array. The accumulator accumulates the callback's return values. It holds the accumulated value previously returned in the last invocation of the callback, or the initial value if supplied. The current value refers to the current element being processed in the array. The index and array parameters are optional and represent the index of the current element being processed and the array ReduceRight was called upon, respectively. The initial value, which is also optional, is a value to use as the first argument to the first call of the callback. To bring this concept to life, let's consider an example. Suppose we have an array of 5 elements, 1, 2, 3, 4, and 5. We want to find the sum of these elements. Using the ReduceRight by C method, we define the callback function as the sum of the accumulator and the current value. When we log the sum, the output is 15, which is the sum of 5, 4, 3, 2, and 1. This method has its advantages. It's particularly useful for operations that require traversal from right to left in an array. It also offers flexibility in customizing the reduction process through the callback function. However, it's not without its downsides. The ReduceRight method may not be as intuitive as other array methods like map, filter, or ForEach. It requires an understanding of the accumulator and callback functions' behavior, which can be complex in certain cases. Additionally, it may not be the most efficient solution for all use cases, especially for simple array transformations. In summary, the ReduceRight method in JavaScript is a powerful tool for reducing an array from right to left. It provides you with the flexibility to customize your reduction process, but requires a clear understanding of how accumulator and callback functions work. While it's not always the most efficient solution, when used correctly, it can significantly streamline your code. Remember, the key to mastering JavaScript is understanding the tools at your disposal, and ReduceRight is certainly one of them.
Have you ever wondered how to test elements in an array in JavaScript? Well, 2 functions can make that job easier for you: every and sum. The every function is a handy tool that tests whether all elements in an array pass a specific test. It's like a strict teacher who expects every student to ace the test. If just one fails, the whole class fails. Here's how the syntax looks: array, every callback, element, index. The callback is a function that each element in the array has to pass. The element is the current item being processed, and index is the position of that element in the array. The array is the one every was called upon. This arg is an optional parameter.
How to locate a specific element's position in a JavaScript array? Well, that's where the JavaScript methods IndexOf and LastIndexOf come into play. The IndexOf function in JavaScript serves to find the first index at which a specified element appears in an array. If the element is not present, it returns -1. The syntax for this function is as follows: array index of a search element from index. Here, the search element is the element you're looking for in the array. The from index, which is optional, is the index from which the search begins. If you leave it out, the search starts from the very beginning of the array, that is, index 0. So, the IndexOf function starts scanning the array, and as soon as it finds the first occurrence of the element you're searching for, it returns the index. If the element is not found, it returns -1. The benefit of this function is that it swiftly finds the index of the first occurrence of an element in an array. However, the downside is that it only returns the index of the first occurrence, not all occurrences. Now, let's switch gears to the LastIndexOf function. This function is similar to IndexOf, but with a twist. It returns the last index at which a specified element can be found in the array or negative one if it's not present. The syntax is almost identical to IndexOf. Array LastIndexOf search element from index. The key difference is that when the from index is omitted, the search starts from the end of the array, not the beginning. So the LastIndexOf function begins scanning the array from the end and returns the index of the last occurrence of the element you're searching for. If the element is not found, it returns -1. It's especially useful when you need to find the index of the last occurrence of an element in an array. However, like IndexOf, it only returns the index of the last occurrence, not all occurrences. To illustrate this, consider an array of numbers. If you use IndexOf 3, it returns 2, which is the index of the first occurrence of 3. However, if you use LastIndexOf 3, it returns 5, which is the index of the last occurrence of 3. In conclusion, both IndexOf and LastIndexOf are powerful tools in JavaScript for finding the position of elements in an array. While they have similar syntax and functionality, IndexOf is useful for finding the first occurrence of an element, and LastIndexOf is useful for finding the last occurrence. Each has its advantages and disadvantages, but understanding how and when to use these methods will greatly enhance your ability to manipulate and interact with arrays in JavaScript.
Ever wondered about the difference between the find and FindIndex functions in JavaScript? Let's dive into it. Imagine you're dealing with an array and you need to locate a specific element. JavaScript offers a myriad of methods, but today we're focusing on two: find and FindIndex. The find function in JavaScript returns the value of the first element in the array that satisfies a provided testing function. If no elements meet this criterion, it returns undefined. The syntax looks something like this: array find callback, element index array, this arg. The callback function tests each element of the array and takes 3 arguments: element, index, and array. The this arg is an optional object to which the this keyword can refer in the callback function. This function executes the callback function for each array element until it finds one where the callback returns a truthy value. If such an element is found, find immediately returns the value of that element. Otherwise, it returns undefined. The advantage of find is that it returns the value of the first element that satisfies the condition, which can be useful for searching arrays. However, it stops iteration once the first matching element is found, which means it may not find all matching elements. Moving on to the FindIndex function. This function returns the index of the first element in the array that satisfies a provided testing function. If no elements meet this criterion, it returns -1. The syntax is very similar to the finder function: array, find index, callback element, index array, this arg. The callback function tests each element of the array and takes 3 arguments: element, index, and array. The this arg is an optional object to which the this keyword can refer in the callback function. Just like the find function, FindIndex executes the callback function for each array element until it finds one where the callback returns a truthy value. If such an element is found, FindIndex immediately returns the index of that element. Otherwise, it returns -1. The main difference from find is that FindIndex returns the index of the first matching element, not the value. This can be useful for locating elements in an array. However, just like find, it stops iteration once the first matching element is found, which means it may not find all matching elements. For example, if you have an array of numbers and you're looking for the first number greater than 2, find would return the number itself, while FindIndex would return the index of that number in the array. In conclusion, both find and FindIndex are powerful tools for working with arrays in JavaScript. While they have similar syntax and offer similar functionality, the key difference lies in their return values. Find gives you the first element that meets your condition, while FindIndex gives you the index of that element. So next time you're working with arrays,
Consider whether you need the value or the location of your desired element, and choose your function accordingly.
Ever thought about the differences between flat and FlatMap functions in JavaScript? Today, we're going to delve into these two functions, breaking them down to their bare bones and making them easy to understand. Starting off with the flat function. This function creates a new array by merging all subarray elements into it. This merging process happens recursively up to a specified depth. If you're wondering what this depth is, it's an optional parameter that defines how many levels deep a nested array structure should be flattened. The default depth is 1. While the flat function can be a convenient method to flatten arrays, particularly when dealing with nested arrays, it does come with a minor drawback. The depth specification might lead to unexpected results if not set correctly, causing unintended flattening of the array. Next up is the FlatMap function. This function is a bit more complex, as it first maps each element using a mapping function, then flattens the result into a new array. Essentially, it's combining mapping and flattening into one function. The syntax for FlatMap is as follows. The function takes in a callback function, which produces an element of the new array. This callback function takes 3 arguments, the current element being processed, the index of the current element, and the array FlatMap was called upon. There's also an optional thisArg parameter, which can be used to refer to the this keyword in the callback function. If it's omitted, undefined is used. Now, you might be thinking, what's the difference between flat and FlatMap? Well, the flat function only flattens the array, while FlatMap maps and flattens the array in a single step. This makes FlatMap a concise way to both map and flatten arrays, reducing the need for separate steps. However, it might not be suitable for more complex mapping and flattening requirements, as it combines both operations into one function. Let's illustrate this with an example. Imagine we have an array, 1, 2, 5. If we apply the flat function to this array, it flattens the nested array, resulting in 1, 2, 3, 4, 5. However, if we apply the FlatMap function with a callback function that doubles each element, it first doubles each element and then flattens the result into a new array, resulting in 2, 4, 6, 8, 10. In a nutshell, the flat function flattens arrays up to a specified depth, while the FlatMap function maps each element and then flattens the result into a new array. Both functions have their own advantages and disadvantages, and their usage depends on the specific requirements of your JavaScript code.
Ever wondered how to check if an array contains a specific element in JavaScript? Or perhaps you found yourself struggling to initialize an array with a specific value? Well, JavaScript provides handy functions for these tasks, includes and fill. The includes function comes into play when you need to know whether an array includes a certain element. It's as simple as calling array includes element from index, where element is the one you're searching for and from index is the optional index at which to begin your search. If from index is left unspecified, the search kicks off from the very start of the array. A key point to remember is that includes returns a Boolean value, true if the element is found and false if it's not. It uses a strict equality comparison, meaning that it checks both the type and value of the elements. Now, the advantage of includes is its simplicity and efficiency in checking for an element's presence in an array. However, it does have a limitation. It performs strict equality comparisons, which might not be suitable for more complex comparison requirements. On the other hand, when you want to fill all elements of an array from a start index to an end index with a static value, the fill function is your friend. It follows the syntax array, fill value start end, where value is what you want to fill the array with. Start and end are optional indexes defining the range to be filled. If they're omitted, the function fills the entire array. The fill function alters the original array in place and hands back the modified array. Its strength lies in its ability to initialize arrays with a static value or reset specific portions of an array to a given value. However, caution is needed as fill overwrites existing array elements, which could lead to unintended data loss if not used carefully. The key difference between includes and fill is their purpose. Includes checks if an array contains a specific element and returns a Boolean, while fill fills elements of an array with a static value within a specified range. For instance, consider an array, array1 equals sign, and an empty array, array2. If you check whether array1 includes the number 3, it will return true, and false for the number 6. Now, if you use fill to fill array1 with 0 from index 2 to index 4 and array2 with a, you'll get for array1 and for array2. In summary, includes and fill are versatile JavaScript functions that make array handling more manageable. Remember, includes is perfect for checking if an element is in an array, while fill is ideal for initializing or resetting array values. However, always be mindful of includes limitations with complex comparisons and fill's potential data loss risks.
Ever wondered how to convert iterable objects into arrays in JavaScript? It's a common challenge many face. But fear not, JavaScript has a built-in function named Array.from that comes to the rescue. It's a handy tool that helps create a new array instance from an array-like or iterable object. The syntax for Array.from is straightforward. It takes up to 3 arguments. The first is array-like, which is the array-like or iterable object you want to convert to an array. Then, optionally, you have map_fen, a mapping function that you can call on each element of the array. Lastly, there's this arg, a value you can use as this when executing the map_fen. What does Array.from undo? It creates a new, shallow copied array instance from an array-like or iterable object. This function is perfect for converting array-like objects such as node list or arguments and iterable objects like set and map into arrays. If a mapping function is provided, it gets called on each element of the array-like or iterable object, and the result is included in the new array. There are several advantages to using Array.from. It can convert iterable objects like set, map, node list, and more into arrays with ease. It creates a shallow copy of the array, ensuring that changes made to the new array won't affect the original object. Moreover, it offers flexibility by allowing a mapping function to be applied to each element during the conversion process. However, like all good things, Array.from has its disadvantages too. Using a mapping function or dealing with large iterable objects may introduce performance overhead compared to simpler array creation methods. Also, Array.from might not be supported in older browsers or environments that do not fully support ECMAScript 6. Here's a quick example. Suppose you have a set containing the numbers 1, 2, and 3. To convert this set into an array, you can use Array.from like so, const array equals sign array from set. Now, array is an array with the same elements as the set. Similarly, you can convert a node list of paragraph elements into an array, or you can use a mapping function to create an array of squares from an array of numbers. In summary, Array.from is a powerful utility method in JavaScript, particularly useful when working with iterable objects and converting them into arrays. It provides flexibility with mapping functions, but it's also important to be mindful of potential performance implications, especially when dealing with large data sets.
Have you ever pondered the power and importance of array methods in JavaScript? These methods can save you a lot of time and effort when dealing with arrays, which are ubiquitous in programming. Today, we delve into the world of JavaScript array methods, focusing on 3 commonly used ones: join, concat, and sort. First up is the join method. This method creates and returns a new string by concatenating all the elements in an array, separated by a specified separator string. The syntax is simple: array.join separator. The separator is optional, and if you leave it out, the array elements will be separated with a comma by default. An example of how to use the join method is as follows. Suppose you have an array of fruits: apple, banana, and orange. If you want to convert this array into a string separated by commas, you would use the code const result equals sign fruits. Join, the output here would be apple, banana, orange. While the join method is a handy way to convert array elements into a string, keep in mind that it modifies the original array. Next, we have the concat method. This method merges 2 or more arrays, returning a new array with the combined elements of the original arrays. The syntax is array.concat, array1, array2, arrayn. The arrays to be concatenated are optional. Here's an example of concat in action. Let's say you have 2 arrays, array1 with the elements A, B, and C, and array2 with the elements D, E, and F. To merge these two arrays, you would use the code const result equals sign array1, concat array2. The output would be the concat method is great for combining arrays without modifying the originals, but remember that it creates a new array, which might consume more memory if used extensively. Finally, let's look at the sort method. This method sorts the elements of an array in place and returns the sorted array. The syntax is array sort compare function. The compare function is optional. If you omit it, the array elements are converted to strings and sorted alphabetically. Here's how you might use the sort method. Suppose you have an array of numbers, 3, 1, and 2. To sort these numbers in ascending order, you would use the code numbers sort A, B equals sign A, B. The output would be. The sort method is versatile and can sort various data types based on custom criteria. However, it modifies the original array in place, so handle with care. In summary, each of these array methods in JavaScript has its unique purpose and use. The join method turns array elements into a single string. The concat method combines arrays without altering the originals. And the sort method arranges array elements in a specified order. Mastering these methods will help you manipulate arrays with greater ease and efficiency.